Okay guys, Mr. Burns here. We're working section 4.3 for trigonomic ratios, and what we're going to begin talking about is the unit circle. But to truly understand the unit circle, you have to understand what we've done so far. So far we've been able to take, when we are given an x coordinate and a y coordinate, we've been able to take that and find a hypotenuse by using the Pythagorean theorem, so that our hypotenuse value is r, our y value is the opposite side, and our x value is the adjacent side of our angle theta, which will always be the acute angle that is next to the origin, with our 90-degree angle being out here with a vertical line and the x-axis. From this we can gather that our trig ratios are going to correspond in certain places. Sine of theta is always going to be y over r, cosine of theta is always going to be x over r, tangent y over x where x can't equal 0, cosecant of theta, r over y, where y can't equal 0, secant of theta, r over x, where x cannot equal 0, cotangent of theta, which is x over y, where y cannot equal 0. So, understanding that, we can move to the unit circle. And all the unit circle does is it changes and standardizes the value of r. So here we have our unit circle, and we can see that our values are 1, 0, 0, 1, negative 1, 0, 0, negative 1. So wherever this radius is drawn, r will always be equal to 1. And what this sets up is it allows us to come from a theta, or be given an angle measure, and be able to determine coordinates at which this angle would fall, okay, based upon your special angles. Okay, so since we've standardized that r is, it's also changed our sine and cosine functions, tangent, cotangent, cosecant, and secant. So now instead of being over r, it is now sine is y over 1, or just y, cosine is x over 1, or just x, tangent is y over x, cotangent is x over y, cosecant is 1 over y, and secant is 1 over x. Okay, so it standardizes it. So let's say we're given a 30-degree angle, and we're asked to find the coordinates at which it falls. So we have 30 degrees, and we know that the sine of 30 is equal to 1/2, and that the cosine of 30 is equal to the square root of 3 over 2. So since we know that sine is going to be our y value, cosine is our x value, the coordinates at which 30-degree angle falls is going to be at the square root of 3 over 2 for the x value, and a y value of 1 over 1/2. Okay, some other things that are going to help you while you're working on your problems is knowing this right here, that all trig functions are positive in quadrant 1, only sine and cosecant are positive in quadrant 2, tangent and cotangent are the only trig functions positive in quadrant 3, and cosine and secant are the only trig functions that are positive in quadrant 4. And then the final thing that is paramount for your problems is you need to know your specials. Okay, so you need to know that the sine of 30, or pi over 6 radians, is always 1/2. Sine of 45, or pi over 4 radians, is the square root of 2 over 2. Sine of 60, or pi over 3, is the square root of 3 over 2. Cosine is the square root of 3 over 2 for 30, or pi over 6. Cosine of a 45, or pi over 4, is the square root of 2 over 2. Cosine of 60 is 1/2. Tangent of 30, or pi over 6, is the square root of 3 over 3. Tangent of 45 of pi over 4 is always 1. And tangent of 60 of pi over 3 is always the square root of 3. This information will be helpful on numbers 26 through 32, 44 through 58.